Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabudiwa Sos Ugobela Wemets. And without any further ado, let's look at this question that we have here. Ah. Okay, so we have question 8 on electric circuits. So it says the battery in the circuit below has an EMF of 5 volts and an internal resistance R. The resistance of the connecting wires in the ammeter can be ignored. Then we have 8.1 that says state Ohm's law in words. Okay, so for 8.1, we are going to say, what does Ohm's law state? State that the potential difference across the conductor is directly proportional to the current through the conductor at constant temperature. Okay, so the potential difference across the conductor is directly proportional to the current through the conductor at constant temperature. That's how you are supposed to define Ohm's law. Now, they are saying switch S is closed and the ammeter reading is 0.4 amperes. So when they close switch S, the reading here is 0.4 amperes, which represents the total current. And then 8.2 says calculate the reading on the voltmeter. So because the voltmeter is connected across the battery, that means this will be reading the external voltage. Now, how do we calculate the reading on the voltmeter? Obviously, we have the total current. We have to find the R external. And then looking at this, we can see that our two resistors here are connected in parallel. So to calculate R parallel or the R external, this is R1 times R2 over R1 plus R2. So I'm doing the product over sum because these are in parallel. So this is 18 multiplied by 6 over 18 plus 6. And then when we punch in our calculator, we get 4.5 ohms, right? Now 4.5 ohms, now we have to calculate the voltmeter reading V external is equals to the current totally multiplied by the R external. So we are going to say 0.4 multiplied by 4.5. Then when we punch into our calculator, we get 1.8 volts, right? So that's it. That's our V external. That's the reading on the voltmeter. Okay, so this was for 8.2.1 4 marks. Now 8.2.2 saying calculate the energy dissipated in the 18 ohm resistor in 5 minutes. Now we know that since we have calculated the voltmeter reading here, and then we found that it is 1.8 volts, we do understand that the voltage here, because this is connected, remember, this is connected in parallel. And then what do we know about resistors in parallel is that they share, they have the same current, they have the same voltage throughout, meant to say. So they have the same voltage throughout. They have the same voltage throughout, but then the current is divided amongst the resistors. Now we just calculated that the reading here is 1.8 volts. So that means this would be 1.8 volts, and this is also 1.8 volts. Mainly because here we don't have any other resistors here that are connected in series to take the voltage. So all of this voltage here that is given as the V external will then also be distributed over here, which is 1.8 and 1.8 there. So it's the same voltage throughout. Okay, so now, how do we then calculate the energy dissipated in the 18 ohm resistor in 5 minutes? Again, the time here must be given in seconds, so this must be 5 multiplied by 60, which if we check there, 5 multiplied by 60 is supposed to give us 300 seconds. And then remember, we are calculating the energy. Formulas for energy, we have VI times delta T. We have also I squared R and then delta T. And then we also have V squared over R and then delta T. Now, based on the information that we have here, which formula can we choose here? We have the resistance and then we also have the voltage. And then we have delta time. So obviously, the correct formula to use is this one. So W is equals to V squared over R and then multiplied by delta T. Our V will be 1.8 and then square that. The resistance is 18 ohms and then multiply that by the time, which is 300 seconds. Now, if you punch all of that into your calculator, you get 54 joules. Remember, it's energy. Energy is given in joules. So, okay, for that 4 marks, that's how you were supposed to go about solving that one. So it's just simply the formula and substitution into the formula and also the conversion there. Okay, nice. Then let's now go to 8.2.3. It says calculate the internal resistance of the cell. Right, so to calculate the internal resistance, we have the formula that goes EMF is equals to the total current bracket, the R external plus the R internal. So the big R here is for the R external, the small r is the internal resistance. Now our EMF we've been given it's 5 volts, so we have 5 here. Then our current, we are told that it is 0.4, and then we did mention that the current in here is representing the total current, which should be the one that goes in there. We did calculate the R external while we were still trying to get the voltmeter reading. So we did calculate it and then we found 4.5 and then plus R. Now, in order to calculate here, you can start by dividing both sides by 0.4. So this is 5 divided by 0.4 is going to give us 12.5. So this is 12.5 is equals to 4.5 and then plus R. Now to calculate R, that's 12.5 minus 4.5, right? So internal resistance will now give us what? If we subtract there, this is going to give us 8, right? So we are going to have 8 ohms. So that right there is your internal resistance. Okay, so now let's then proceed. 8.3 says, how will the reading on voltmeter V change when switch S is open? Choose from increase, decrease, or remain the same. So now we are opening switch S. So if this one is open, that means that the current will only flow in this direction here. So this is your current here. So obviously it will not go in here because it will not pass over there. So that means your current will only go here, and then this here would have to be the only resistor that's connected in series, right? So there goes your current, and then it will go like that. Now note that initially, if we were to consider these two resistors connected in parallel, we found that our R external was 4.5 ohms. But now that it is only connected in series, our R external would have to be 6 ohm. Now, this is the observation that we have. We have the observation that says that our R external will increase, right? But then based on this, we know that if our R external increases, R is equals to V over I. If our R external increases, then the voltage that has to be supplied has to also increase, right? Because with more resistance, we need more of that energy that will push the current. So our V external will have to increase. So our voltage will have to increase. And then for 8.3, we will say it increases. It increases. Right. So increasing the R external increases the V external. Okay, so that's how it goes. They did not need any explanation though, but then just for you to understand how I came to that. Okay, so that's how you were supposed to tackle this question, all for a total of 15 marks. So you know what to do. If you have enjoyed the lesson, please press the thumbs up button. And then if you've been watching the videos and haven't subscribed yet, please, please, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.